Alright guys, let's talk about multiplying and dividing rationals. First off, you guys know how to multiply and divide rationals, or fractions I should say. So don't forget, rationals just means fractions. So for example, if I had, if I had 1 divided by over 2 times 2/3, that's essentially going to be 1 times 2 over 2 times 3. But what we know is that what we can do is to cancel something from the top with something with the bottom, and as long as they're the same, or it can reduce, and so on. So this way, this is going to equal to 1/3. Okay. And when I talked about reducing, so let's say I had 1/4 times 2/3. Okay. So same thing. I got 1 times 2 over 4 times 3. So 2 goes into 2 once and goes into 4 twice. So therefore, what I know is that this is going to be 1 times 1 over 2 times 3. Okay. The only difference between that and what we're about to do is going to be that the top and bottom are going to be, how should we say it, going to be factorable. So it could be 2 terms, which is, you ask the question if it's the difference of 2 squares. It could be 3 terms, where you can use the AC method, or it could be 4 terms, which is factored by grouping. So let's go ahead and write that down. So top and bottom could be, wow, that looks awful. Could be 2 terms. So we would ask ourselves, is it the difference of 2 squares? It could be 3 terms. We would do the AC method, or trial and error. And if it's 4 terms, then we would do factor by grouping. But don't forget that the very first step is going to be GCF. And then we would go into it. Actually, let's do it this way. Then we would go here, or here, or here. Okay, so we already know that. All right, so I'm going to give you some steps here. Step 1, actually, you know what, let's write this down. So when we multiply, rationals, here are our steps. Step 1, we're going to factor, oh boy, oobly, factor top and bottom, meaning the numerator and denominator. Step 2, we're going to find restrictions. And how do we find restrictions, guys? We don't need that. Set the bottom equal to 0. Okay? Actually, let's do it this way. All right. And third, we would simplify. Okay? All right, so let's start an example. We'll start with something simple. For example, let's go with 10x plus 10 over 3x plus 9 times x plus 3 over 5x squared minus 5. All right, so step 1. Factor top and bottom. All right, so let's see. The top is going to be GCF of 10, leaving me at x plus 1. The bottom is going to be GCF of 3, leaving me with x plus 3 times x plus 3, and I would recommend that you put parentheses around these binomials, just so we know it is one whole thing. And then we have a GCF of 5, leaving with x squared minus 1. Well, we're not completely factored yet, because this right here is the difference of 2 squares. So let's keep on factoring. So we got to rewrite this. 10 x plus 1 3 x plus 3 x plus 3 5 x minus 1 x plus 1. All right. So now step 2, we need to find restrictions. Okay, so let's see here. So in order to find restrictions, we're going to set the bottoms equal to 0. So we have 3 equal to 0. We have x plus 3 equal to 0. We have 5 equal to 0. X minus 1 equal to 0. And I wrote it too big. So let's try that again. 3 equal to 0. X plus 3 equal to 0. 5 equal to 0. X minus 1 equal to 0. And x plus 1 equal to 0. So we know that these two are nonsense, because 3 can never equal to 0, nor can 5. So we have x equals negative 3. We got x equals 1 and x equals negative 1. So those are my restrictions. So my restriction is going to be x cannot equal to -3, -1, or 1. All right, so those are restrictions. Perfect. So step number 3 was for me to simplify. Okay, so now I get to rewrite the whole thing again. So I'll bring it down to here. Let me see here. Let me move things around a little bit. So restrictions. With that. I'll bring this up to here. Waste less space. All right. So then we basically have 10 times x plus 1 times x plus 3, because when we multiply straight across. So it's top times top, bottom times bottom. The bottom is going to be 3 times 5 times x plus 3 times x minus 1 times x plus 1. So now what we want to do is go through the top and say, okay, is there anything that are in common, that can reduce, that can do whatever? So first of all, 10. When we look at 10, we can see that will get erased. When we look at 10, we can say that 5 goes into 10 once. 5 goes into 5 once and goes to 10 twice. Then we look at x plus 1. There is an x plus 1 on the bottom. Is there x plus 3? Yes, there is. And that's it. That's all we got. So therefore, on the top, we have left a 2. That's it. On the bottom, we have left a 3 and an x minus 1. So therefore, that is my answer. All right. So let's try another example. Uh-oh. Let's try this one. X squared minus 6x minus 7. We have 3x squared minus 147 times x squared plus 14x plus 49. And then the bottom we have 2x squared plus 16x plus 14. All right. So we said that's step 1. Was to factor top and bottom. So when we factor these, don't forget GCF first, and then ask ourselves if it's 2 terms, 3 terms, or 4 terms in terms of what's left. So if you do the AC method on top here, you're going to get x minus 7, x plus 1. On the bottom, you have a GCF of 3, leaving with x squared minus 49 times. The top here, you're going to get, if you do your AC method, it'll be x plus 7 times x plus 7. On the bottom, you're going to have a GCF of 2, leaving with x squared plus 8x plus 7. So clearly we're not done factoring because we have the difference of 2 squares on the left side. And we got trinomial on the right side, right bottom. So we got to go through the AC method there. So let's rewrite this. So this bottom is going to be 3 times x minus 7, x plus 7. Top here is x plus 7, x plus 7, and then GCF of 2, leaving me with x plus 1 times x plus 7. All right, so now we have completely factored these. So step 2 is to find restrictions. So we're going to have 3 is equal to 0, x minus 7 equals 0, x plus 7 equals 0, 2 equals 0, x plus 1 equals 0, and x plus 7 equals 0. So again, these are nonsense. So we got x equals 7, x equals negative 7, x equals negative 1, and x equals negative 7. All right, with that being said, that means my restrictions are that x cannot equal to negative 7, negative 1, and 7. So make sure that you rewrite these negative 7s twice. You don't need to write it once, okay? So step 3 would be to simplify. So I'm going to rewrite this and multiply them. So I have x minus 7, x plus 1, x plus 7, and x plus 7. The bottom is going to be, the bottom is going to be 3 times 2, x minus 7, x plus 7, x plus 1, and x plus 7. So now we're going to go through and say, is there x minus 7 on the bottom? Yes. Is there x plus 1? Yes. Is there a x plus 7? Yes. Is there another x plus 7? The answer is yes. So all those cancel out. So I'm left with 1 over 6, comma, x cannot equal to negative 7, negative 1, or 7. So that would be my answer. With that being said, however, that means I gotta go back up here and change this answer as well, because I have to say comma, x cannot equal to negative 3, negative 1, and 1. Whoa, that looks wacky. All right, so that's multiplying. So with dividing, there's a little bit more. Okay, so with dividing fractions, or rationals, remember that when we do something simple like 1 divided by 2 times 3 divided by 2, I'm sorry, not divided by, what am I thinking? We're talking about dividing. Divided by, what we actually do is, as you guys call it, keep, change, flip, I call it copy, change, flip. Maybe I should write those out. All right, so what we do is copy the first, change division to multiplication, and flip the second. And then we have to reduce. So there's a 2 on each side. So therefore I have 1/3. Okay, so the only difference is that it's copy, change, flip. However, when you flip, you're going to have a brand new denominator. So we're going to have to put in a couple more steps here just so that we have it. So step one. Okay, let me do this. Dividing. Rationals. So with dividing rationals, step one is going to be factor top and bottom. Step two, we're going to find restrictions. Step three, copy, change, flip. Step four, we're going to find more restrictions because we're going to get a brand new denominator in that second fraction. And step five is to simplify. All right, so let's do an example. So let's do x squared minus 5x minus 24. The bottom is going to be 3x squared minus 192 divided by x squared plus 11x plus 24 over x squared plus 16x plus 64. So the first step, step one, is going to be factor top and bottom. So if we do the AC method, you're going to get x plus 8 and x, it's going to be x minus 8 and x plus 3. The bottom has a GCF of 3. You get x squared minus 64 divided by AC method here, x plus 3, x plus 8. And the bottom, with the AC method, we're going to have x plus 8 times x plus 8. We have a difference of 2 squares, so let's go ahead and rewrite all of it and finish that off. The bottom is going to be 3 x minus 8 x plus 8 divided by x plus 3 x plus 8 over x plus 8 times x plus 8. All right. Step 2. Find restrictions. So 3 equals 0, x minus 8 equals 0, x plus 8 equals 0, x plus 8 equals 0, x plus 8 equals 0. So we know this is nonsense. We got x equals 8, x equals negative 8, x equals negative 8, x equals negative 8. Sounds like a broken record. So my restrictions currently is that x cannot equal to negative 8 and 8. Let's see here. Yeah, that's a good color. Step 3. Copy, change, flip. So that's what we're going to do. We're going to have x minus 8, x plus 3 over 3 times x minus 8 times x minus 8. That's the copy. We're going to change division to multiplication, and we're going to flip this one. X plus 8, x plus 8 over x plus 3, x plus 8. So there's my copy, change, flip. Step 4 was to find more restrictions. So if you notice that this and this are both the new denominators that are added to this, so we'll just set x plus 3 equals 0 and x plus 8 equals 0. So we got x equals negative 3 and x equals negative 8. Well, in my restrictions, I already have negative 8, so I just have to add the negative 3 in there. So essentially, my restrictions now are x cannot equal to negative 8, negative 3, and 8. All right. So now, yeah, we'll do that. So now, step 5, we can simplify. So if that's the case, let's multiply the tops. X minus 8, x plus 3, x plus 8, x plus 8, and then the bottom is 3, x minus 8, x minus 8, x plus 3, x plus 8. So is there an x minus 8? Yes, there is. Is there an x plus 3? Yes, there is. Is there x plus 8? Yes, there is. And then is there another x plus 8? No, there's not. So therefore my answer is going to be what's left, which is, x plus 8 over 3 times x minus 8, comma, x cannot be negative 8, negative 3, and 8. All right, so this is the end of the notes. Hopefully you guys understand, and